Okay, here we are at 4-4, day 1. Okay, we're going to look at some new derivative rules, and it's going to be the other 4 trig functions. And what we're going to do is develop the rules. I'm not just going to give them to you, and you will have to repeat at least one of these on a quiz or a test. So, if you take yourself back to trig class, each of the other 4 trig functions can be written in terms of sine and cosine. For instance, we'll start with secant. The secant, if you remember, is the cosine flipped over. And if you don't remember that, they're all on the back of your blue sheet. So your secant equals 1 over cosine. So we're going to rewrite secant as 1 over cosine. And because we know how to do the derivative of a quotient, we can discover the derivative rule for secant. So we're going to let y equals secant x, and secant x equals 1 over cosine x, and now we're going to do the derivative of this. So y prime, think of it as a u over a v, or we could rewrite it with a negative exponent. I guess it doesn't really matter. I'm going to go u over v. So the u is a 1, and the derivative of 1 is 0, times by the v, subtract the top, multiplied by the derivative of the bottom is negative sine x, all over the bottom squared. Simplifying this, we'll go horizontally here, that's 0, that's gone. Then we've got this negative that's going to get pulled out, and then multiplying by 1 gives me a sine x over cosine squared. Okay, we can do a little bit better than this for our derivative if we think about cosine squared as cosine times cosine. So I'm going to break the bottom apart. I'm going to leave the top as sine x. The bottom's going to get broken up as cosine times cosine. Then what I'm going to do is break this apart into 2 separate fractions, because you're going to see that these are going to simplify. So I can break it apart as sine over cosine, and then this other fraction I can multiply by 1 and not change that, is 1 over cosine. Well, each of these is their own trig function. Sine over cosine, if you remember, and if you don't, it's back here, sine over cosine equals tangent. So this fraction here simplifies to tangent. 1 over cosine is secant. So we just came up with a derivative rule for secant. It's tangent times secant. Well, the book actually flip-flops these. Starts with secant times tangent. So, on your blue sheet, you're going to add in your secant rule. So the derivative of secant we just found was the secant of the angle times the tangent of the angle. And the one thing that doesn't come through is the derivative of the angle. I never did do that because the derivative of x is 1. So I just kind of left that behind. But this is enough to develop the formula for it. So the derivative of secant is secant of the same angle times the tangent of the same angle. I'm using u for the angle. And then don't forget to multiply by the derivative of the angle. Alright. So we've got 3 more to do. Let's go with cosecant. Starting with cosecant. Remember, cosecant is sine flipped over. And again, you don't have to remember that because they're back here. Cosecant is 1 over sine. Now we'll go into the derivative of this and see what the cosecant derivative rule is going to be. So quotient rule, u over v. Derivative of 1 is 0 times sine minus the top, derivative of the bottom is cosine. That would be times 1 all over bottom squared. Simplifying that, that's 0, goes away. We get negative cosine over sine squared. And to simplify this, I'm going to do the same thing. I'm going to think of that as sine times sine and break it apart into two separate fractions that turn into two separate trig functions. So negative cosine x over sine x times the other thing I can put up here is a 1 over sine x. Okay, cosine over sine is a trig function. Cosine over sine is cotangent. So we've got a negative. So we've got negative cotangent x, 1 over sine. We used that at the beginning. That's cosecant. And again, the book just flip-flops these. So the derivative of cosecant, the rule is going to be negative cosecant x, cotangent x. Just switching the order there. So, add that new rule to your blue sheet. Cosecant is negative cosecant of the angle, u, times cotangent of the angle, u, times by the derivative of the angle, u prime. Alright, tangent and cotangent are left. So we'll start with tangent. And your goal is to rewrite the trig function with sines and cosines, because we had, those are the two rules that we knew to how to find the derivative of. So tangent is, if you look on the back of that blue sheet, sine over cosine. We'll do the derivative of that, which will give us the derivative rule for tangent. And again, like I said, you will have to know how to do this coming up with the rule. You'll have the answer on your blue sheet, but you got to have all the steps to verify it. Okay. Derivative of the top is cosine, times by the bottom is cosine, minus, keep the top, derivative of the bottom is negative sine, all over bottom squared. Alright, simplifying. Cosine times cosine is cosine squared. Here the negative is going to come out. We're going to have plus sine times sine is sine squared over cosine squared. Okay, cosine squared plus sine squared. Simplified. I am not allowed to break this up into cosine squared over cosine squared plus sine squared. That's not legal to break that apart with an add sign in the middle. So, cosine squared plus sine squared is a trig identity. It's one of our Pythagoreans. Cosine squared plus sine squared, if you remember from last year, does equal 1. The chances of you remembering all this from last year are pretty slim. That's why you have this whole sheet to refer back to. So the top simplifies to 1 over cosine squared. Well, again, break this apart. Break that cosine squared up into cosine times cosine, and the two fractions are 1 over cosine times 1 over cosine. Well, 1 over cosine is secant times secant. That just simplifies to secant squared. So the derivative of tangent is secant squared. Add that to the back of your blue sheet. Derivative of tangent is secant squared of the angle, u, whatever it was, but then don't forget, we multiply by the derivative of the angle at the end, because it's an inside-outside business. Okay, last one is the cotangent. we start with cotangent. Rewriting, so you see sines and cosines, not 1 over tangent. We don't want that. We want cosine over sine, and now derivative. So, derivative of cosine is negative sine times the bottom minus the top times the derivative of the bottom, cosine, times 1, I'm forgetting that all the way through, all over bottom squared. Okay, so we've got a negative sine squared minus cosine squared all over sine squared. Oh, don't be canceling these either. Remember with an add or subtract sign, they're holding hands, and I can't cancel if it's holding hands with another term. So no canceling. What I can do, if I look, I won't find negative sine squared minus cosine squared on there. But if I factor a negative 1 out of both of these, so in other words, take a negative 1 out of the basket, that will leave me with a plus sine squared, a positive sine squared, then a plus cosine squared, all over sine squared. If I distribute the negative 1 back in, I'm right back to what I had. This is that Pythagorean identity again. This simplifies to 1. Sine squared plus cosine squared does equal 1. So, that'll be negative 1 times 1 over sine squared. And I think you can see the two fractions we're going to break it up into. Negative 1 over sine times 1 over sine. So this would be a negative cosecant times a cosecant, and we get a negative cosecant squared. So, adding that rule, derivative of cotangent is negative cosecant squared of the angle, and then times the derivative of the angle. Okay, one thing to notice. And this one. All of the functions that start with a C, cosine, cosecant, and cotangent, every one of their derivatives starts out with a negative. The other three functions that don't start with the C, the tangent, the secant, and the sine, none of their derivatives start with that negative. So that's just something that's kind of easy, help you to remember. If the function starts with a C, its derivative has a negative. Okay, now we're just going to use these rules today. And we're going to spend another day on it too. We're not going to be a steamroller through this section. But again, you will have to regenerate that process at some point. So just a few examples to use it. Here we go. Differentiate. All differentiate means is find the derivative. So we'll start simple. Let's go f of x equals cotangent 5x. Derivative then, make sure you use the right notation. Cotangent's derivative